Hi people, I am here to clear your simulation concepts. Simulating a circuit before implementing it practically is the most important and challenging task, as it gives you the expected result of the schematic. In this video by Assignment Co., I am going to introduce you with the user-friendly and accurate software MULTISIM, and will explain the graphical analysis procedure on MULTISIM. As graphical analysis of any circuit seems to be a tricky task, so I'll teach you a convenient and easy method of performing wave analysis. Let's design a triangular wave generator using DC supply and op-amp. For this, firstly, we'll have to design a square wave generator using oscillator circuit and an RC circuit to convert square wave to triangular. You can see the complete circuit schematic on the screen. Though it seems to be a complicated design, but believe me, it's too easy to implement using MULTISIM. Now let's begin with the designing of the oscillator circuit first. I've already designed it to make things easier, but I'll show you how to place the components and make a new file. Now, first select New File and a blank document. And now in the toolbar, you can see different component symbols, so select the resistor symbol. From here, you can select resistor, capacitor, electrolytic capacitor, etc. So we will select resistor. Then we will select an electrolytic capacitor. You can select any value later on. You can change the values by double-clicking on the component. So now from the drop-down menu, we will select sources, and from here we can select ground, and we can select VCC, and VEE needed for our circuit. And the main component is op-amp, so we will go in analog library from here. We can find the required op-amp, and here you can type in search bar whatever you want. So here it is, LM124N. Select OK, and now select A. Now place the component and select cancel, and again cancel. Now to make the connections, I'll show you how to do it. You can flip the component vertically by just right-clicking on the component and select flip vertically like this. Now to make the connections join ends of the two components, and here the connection is made. And you can change the value by double-clicking it and make it 15 volts, okay? And similarly, you can change the value of resistor, which I'll teach you in detail later. Now we will see the circuit. Here the circuit is. Now place the oscilloscope and we'll connect the positive terminal of channel A to the output and place one more ground from the in use list. Here we get the components which are already in use in the circuit. Now we will connect the ground to the negative terminal. Now play the simulation, you will get a square wave. Now we will increase the volts per division so you can see it clearly. Here's the square wave. Now generate triangular wave, that is convert square to triangular, we'll stop the simulation. Now we have to add capacitor, so we will add capacitor of any value and one more capacitor. Okay, cancel it. Now we'll take the resistors from the in use list and one more resistor, okay? And a ground. Okay, now we'll rotate. Right click on the component, select rotate 90 degrees. Rotate it also 90 degrees. Now connect this to the output of the square wave and connect this with the capacitor. Now bring the ground here. You can move the components by just dragging them. Now connect this. Connect the ground and bring the resistor here. And now make the connection. Now set the values, double click on the component and retype the value. Here we want it to be 1.5K, and other resistor also has to be 1.5K, and the capacitor to be 2.2 micro. And now make the connections. We will connect the channel B to the output and negative terminal to the ground. Okay, now again play the simulation. Check the oscilloscope, double click on the oscilloscope. Here you can see a square wave and a triangular wave. Now we'll have to stop it, so we will click on single and it will stop. Now move the cursor to see the peak to peak values. We move the cursor to the minimum value and 1 to the maximum value. Now you can see the channel A gives 10 volts maximum and minimum negative 15 volts, so difference is 25 volts. Similarly, channel B values are for triangular wave and maximum is 5 volts and minimum is negative 5 volts. so difference is negative 10 volts. So now you are done with it, and I hope this video has increased your interest in simulating circuit using MULTISIM. Thanks a lot for watching our video. Bye.